Hello, welcome to the Structural Engineering Podcast. We're your hosts. My name is Max.
And I'm Zach.
And we're here to talk about structural engineering.
We sure are. This is episode number 1.
Every week or so, we like to get together and talk about kind of what's going on in the industry, looking at new tech innovations, looking at cool projects around the country.
A little bit about what we do.
A little bit what we do, like day-to-day of engineering.
Yep.
And
maybe some issues that we come up, that we work through. And
yeah, a little bit of everything.
A little of everything, yeah. This is for, I would say, anyone from practicing engineers to students to anyone that's even interested in engineering.
Absolutely. We're going full spectrum.
Full spectrum.
Anybody.
Yeah.
It's for anybody.
Yeah, absolutely. So, well, yeah.
What are we talking about today?
I think today we should go over our, first week as a new engineer.
Week.
First job, first week.
Yeah.
What it was like, how scared you were, the things that you went through.
In my pants.
Yeah, I think we need to get that out on the
All
podcast.
The details, yeah.
Yes. So,
Yeah,
do you want to take it off? You want to start?
Yeah.
And we'll jump into my first job.
Okay, let's do mine. Well, where do you start?
This gets interesting.
Okay. So before, I'm going to really quickly say that most people...
Give a little education background.
Yeah, a little education background, right? Most people, they go to college, they get an engineering degree, civil or architectural. Is there structural specific? Kind of, not really.
There's what I got was a civil
structural.
Civil structural.
Okay, I was civil structural. But first time I did architecture.
Okay.
That's not structural at all.
No.
I don't know why I did that. It didn't make any sense. So I worked for a little bit.
Okay.
Decided...
As an architect?
As an architect. Decided, got my feet wet in the construction industry, which ended up being very good.
Yeah.
But I wanted to be structural.
You can sympathize with architects
I
now.
can sympathize with the architect.
Yeah.
So, okay. After not too long, a couple of years, I went back to school in Colorado, and I got a civil structural bachelor's degree. So that's where I started from.
So you have double bachelors.
I got dub bachelors.
All right.
Dub batch.
Dub batch. What a man.
Too much school. So that's where I'm starting. So day one, this is an internship. My first internship, which moved into my first job.
Okay.
So this is my first, maybe my second semester in the civil structural program.
Okay.
So I was kind of equivalent sophomore, junior, kind of in the middle there.
Yeah.
I had some stuff knocked out.
Yeah, you've already learned some structural stuff.
I know, what's a door and a window.
Okay.
I knew more than that.
Yeah.
Wall, roof.
Yeah.
But not.
You know how to design beans.
I didn't know how to design beams.
Okay.
No, I didn't know beam.
Okay.
I knew wall.
But this is during your structural bachelor's.
Yes, during structural.
Okay.
I hadn't gotten to beam yet.
Yeah, sure.
Okay, so I got a job internship. This job posting came through our job board through the school, responded, said, hey, I'm basically an architect. Can I be a structural engineer? And they said, sure, you can be an intern. And this was a pretty small firm, right? They did structural and civil, which is fairly common, right?
Yeah. I think that's...
Right. And it was about 5 guys total. When I started, there was a signing principal engineer, the only PE in the office.
Mm-hmm.
Another guy, was pretty good, and then it was me, an intern.
Okay.
All right. And
it's quite the narrative we got going on.
Pretty much as soon as I started, this guy passed his PE and decided to go open a new branch of this firm down closer to his house. Mm-hmm. And then right after he quit, so it was just me.
Okay.
And the signer. So day one, which is what we're talking about.
Yeah.
So day one, okay. Walk in, you sign your stuff.
Your life away.
Sign life away, a couple hours being I won't cut myself paper cuts or whatever.
Right. You got health insurance.
Yeah, I got health insurance. Yeah. Go easy on the mouse.
401k, whatever.
401k, you're good.
Yeah.
Okay. So first project, principal comes over. He has drawings of a canopy sort of thing, on a commercial building.
Okay.
This fabric aluminum tube frame thing. He says, "Here, design this," and that's it. He kind of walks away. That's all I get. Design this.
No direction.
No. Just design this. And I'm a little nervous. A little bit. I feel like maybe for a very long time, but it could have just been one of those things that happens quick. I was freaking out because I don't know what the hell. So anyway, I'm looking at this just kind of frame, and I start thinking all right, this is statics. This is a truss.
100%.
I know.
Yeah.
I did. There was a class for this.
Yeah.
I could do a truss. So I from the architecture background, I kind of, you know, I had an idea on wind loads and snow loads and whatever. So
Yeah.
right, I figured out what those were. I don't know what I probably Googled that for for half a day.
Googling
What
is key
are
as a new
these snow
engineer.
loads? Yep.
Yeah. Were they right, you
and
think?
Do
Do you remember?
I think they were right. I don't know.
Like the science engineer must have corrected it at some
I
point.
hope so. He probably just didn't even tell me. I was like,
Yeah, he probably
we'll
wouldn't.
just bump this up a little
Yeah,
bit and
yeah.
call it. He was casual.
Okay.
He was casual.
Yeah.
Yeah, so you get your loads, right? And I made this very complex RISA model, the structural engineering software.
Yeah.
Right? Went overboard, hardcore, because I didn't know what you're supposed to do.
So, like, did you model fully in 3D?
Fully in 3D,
Okay.
for sure.
And you just loaded
I
everything with,
loaded
like,
all
every load
sorts
you could
of
imagine.
wind and snow in every direction, and the
Okay.
thing was, like, moving all over the place.
Did you have any
Dynamic.
experience with RISA at that point?
I don't think that I did.
Okay. So, wow. So, you had to learn a whole program and a canopy
Yeah. Well, it took
Okay.
a really long time,
all at once.
all at once.
Yeah.
So yeah, I think I probably drew a really detailed picture because I like to start with that. If I can't think of what to do, the nicer my picture is, the less I know what's going on.
Okay.
So I definitely drew a very nice picture.
Oh, yeah.
Right.
Yeah.
There was probably an axonometric, like from every angle, all sorts of stuff. Loads on this thing, RISA, and yeah, like 3 days later, we had a canopy.
Huh.
And I mean, this is a little while ago. I'm having a hard time remembering, like, did I do everything wrong? I
Yeah.
probably did.
More than likely.
than likely.
Yeah, I think everyone does on their first job.
I mean, it definitely took a really long time, but
How long would it take you now?
it would take me like an hour.
Okay.
Yeah.
Yeah. Even with aluminum?
Ah,
Aluminum's a little special.
am I detailing? I guess I was drafting then,
Yeah.
too. Maybe half a day
Okay.
minus.
Yeah.
I don't know.
Okay.
Yeah.
Did you design any connections?
No.
Just the tubing?
No, this is just tubing.
Okay.
This is just some, like, pre-manufactured tubes.
Like a catalog item.
Catalog kind of thing.
Okay.
Some of the ones later on in this sort of thing, yeah, it was just like an extruded aluminum with some little insets like for hanging stuff. But this was just like basically an HSS, but for not structural steel, for aluminum.
Yeah.
And yeah, didn't do any connections. I did do the connection to the building. Remember that? That
Huh.
was very, very confusing.
What kind of building? What was your back? What did you attach it to?
I
Do
don't
you
remember. I ended up, in the time of this internship and job doing so many of these canopies, but it was like, how many nails do I need to go into? I definitely didn't think about anything like how close can the nails be. 8 inches on center doesn't make any sense if there aren't any studs behind. What am I attaching this to? It's just like find the number, divide it by what you got. There's the answer.
Nails at 5.3 inches on center.
Yeah, I think I was probably going in like studs or studs or something.
Yeah.
That was it. I sized. So yeah, out of this catalog, you get the modulus elasticity, get the moment of inertia, find the stress, make sure the yield stress is more than that.
But you knew to do all those
I knew to do all those.
and you didn't have direction to do that.
No.
Okay.
But I think I got lucky because I had a little background. I had enough that I kind of knew what to do. I didn't ask enough questions, that's for sure.
Yeah.
I think that's pretty important.
So you went back. It was kind of more or less for the listeners. If you were to go back and think about it again, how you do it differently, what would you do? Again, you don't know anything, right? So
I still don't.
like you're saying, like would you think it would be a good suggestion to ask more questions when you start your first job?
Oh yeah, so many.
Is there too many?
There's not too many.
Okay.
Unlimited.
Now the
I
idea
should have
of
spent 3 days on questions, and then I could have designed in 30 minutes instead of 3 days on design.
Yeah.
Absolutely.
Huh.
Because if you don't know the region, there could be a special wind region. The snow load may not be reducible like it is here in Colorado, in our specific area of Colorado.
Yeah.
There's a lot of stuff, and I think he's probably made some assumptions. I don't know if it was right or wrong, but I think like the questions that's what I would redo.
Ask more
And I
questions.
probably wouldn't have even bothered with a computer, honestly. That is so unnecessary.
Yeah.
In this little stuff.
Such a big model.
Yeah. I
Yeah.
think a lot of people are quick to just like, show off their computing prowess.
Yes.
Look at this.
And
This
I think
model.
that's something we all kind of get stuck in too, is, even people with experience, you see all the time, like, the model works, so it must work. But then once you start diving into it, you're like, does the moments and shears make sense somehow? And a lot of times it doesn't, because you didn't model it correctly, you didn't put the load on there correctly, or something like that. And it kind of takes that, like, knowledge of that you did it by hand before, for less complex things, and then when you get into complex things, you can understand it better.
Absolutely.
Because you know how it works by hand, more or less, shear moment diagrams.
Yeah. So that was it. I mean, that was my first few days, and then if we're going like full first week
Let's
here,
do full. What was your second?
I mean,
do you remember?
It was not really.
That's okay.
I know. I'm gonna assume it was a house because this place did a lot of residential.
Okay, wood house
and a lot of wood house.
Okay,
a lot of prescriptive design.
Okay.
And
what does that mean?
So that's
for
just
people
like,
that don't know.
You're looking in the code book.
What code book?
International Residential Code, 2000 whatever it was.
Something
12.
different than you'd use for commercial.
Yeah, that'd be like IBC, International Building
Code. Residential code.
Residential, that kind of thing. Yeah. So
absolutely. Yeah.
So they got these tables, and it says like, all right, you have a floor. The dead load is 20, and the live load is 40. Pretty typical residential. You could put a 2x10 at 16 inches on center at this span, and you're good. Yeah. And you don't have to do anything.
Yeah. Because you just pick it out of a table, more or less.
Someone else did it.
Yeah.
You assume it's fine. You assume the wood species is, it gives you the specific gravity of that species, I think. So,
yeah.
We don't do that really as much anymore. There's not a ton of firms that go straight out of the book.
Yeah.
It's a lot easier just to run in a computer, even though I just said you don't have to do that.
But okay.
It's keeping track of your calcs and stuff. The computer's nice for that. I like that.
Yeah.
It's like everything, you can label the joist 1. It's just in there for good.
Yeah, absolutely.
But yeah, definitely the next thing was a house, and man, I bet you that took months.
Really?
I think it was a slow-paced firm for sure.
To give perspective, what would it take now?
A house?
Yeah. Now that you got 4 years, 5 years, 4 years?
I did.
How many years of experience do you have now?
Straight structural, just structural.
Just overall structural experience.
Overall structural, yeah, like 5.
5 years, yeah.
Not a ton. And then about a year.
Okay, so from week 1 to 5 years later, that took. How long would you say that house would take then versus now?
Several weeks.
Okay.
Several weeks.
Yeah.
And now it'd take about 3 days or something. Yeah. I think it's reasonable to draft and.
Yeah. And so I think that's a good point too to talk, like, just to mention, is like when you start.
Oh yeah, time is like such a big thing.
Take forever, but like you just get quicker.
Yeah.
So like don't worry about it. Like you'll just get better.
And there's hopefully no expectation at whatever job you're at. Hopefully the guy isn't like, this should be a quick project. That would be the worst. You know?
Yeah, absolutely.
Yeah. It should be as long as it takes.
Yeah, and I think a good manager understands that, because they were at the same spot one day, right? And I think some people need to be reminded that, like, hey, you started off like this too. But for the most part, I totally agree.
Yeah. Well, let's talk about yours, because I think there's going to be a lot of overlap here. What is your first week?
Yeah, absolutely. So, I think a little back of how I even got to the first week, but kind of like, I would say like the last month before graduating probably was a little late to applying for jobs. So I kind of massively applied, right? So I applied
your civil structural
degree from Washington State University, out in Pullman, Washington, and I probably sent out about 80 applications, cover letter, resume to firms. I heard back from firms in California, Arizona, Washington, Oregon, and Colorado. Ended up taking a job in Washington. Interview went really well. Really liked everyone that I met with there, and it was great. And you know, you're nervous going to an interview and stuff, but I think there's some technical things. And I think that's another podcast we can go over.
Oh man, yeah. I was gonna ask some questions, but maybe it's better on the way.
Yeah, I think another podcast we go over like the interview, how to prepare, kind of things you go in so nervous, and it's just like you're sitting there. We'll go over this in more depth in another interview, but you're just sitting there.
It's just a conversation.
It's just a conversation.
Yeah,
like they're just other people, right? Yeah. Like there's nothing to be nervous about.
I think right in the beginning, people forget that that you're all you want to make sure that you want to work there. It's not just like, can I get this job? It's like, does this work?
Absolutely.
And those first couple jobs, people don't think about that.
Yeah, no, not at all.
But we should cover it later. We'll cover it later.
We will definitely have, if not a couple podcasts on that. Really.
Yeah.
So interview went well, got the job started, and so that gets us to the first day, right?
Okay.
So the first day, just like you went in, did the paperwork and whatnot, and met with HR, and you do all that stuff. You get your desk. You're like, oh, it's so cool. Actually, something really funny is I showed up on my first day of work with nothing. I didn't bring books.
That's not good. I'm glad you mentioned that.
I got to tell you, I didn't even bring a calculator.
That's not good.
So I left from graduating to moving and all that kind of stuff. The box I had with all my books, my calculator and everything was left at my dad's house.
Oh.
Yeah, so my first week as an engineer, I didn't have a calculator. I didn't have books. I was super embarrassed about this, and I think this is funny to bring up. Like the third day, I was on the internet, trying to use a more complex calculator or whatever.
Scientific calculator on the internet?
Yeah, exactly. And people were walking by, and I kept closing it really quick. I was super embarrassed. I was kind of sscared to ask for a calculator. No one would have cared though.
No.
Thinking back, no.
Everybody, a couple.
So I ended up going to the grocery store the next day on my way into work, and I picked one a really bad one up. That was a mistake. Let alone there, which broke the other day actually.
Oh no.
Yeah. I took it to take the PE.
Yeah.
And I brought it back, and one of the books smashed it and destroyed the screen. So kind of funny,
yeah.
It lasted.
It was the EI calculator. It's done now.
It was the EI calculator. Yeah, exactly. So, I think that's a really funny part of right when I started off. I got down to HR and they're like, all right, you can go out and get your books and get your desk and everything set up. And I said, I didn't bring any. All right, oh, okay, bring them tomorrow.
Yeah.
I was okay, sure. I was really nervous. For some reason, I thought if I didn't have books or a calculator, they're just gonna fire me.
Yeah.
That's not at all gonna happen though.
It's a side note though. It's I did bring everything, but I felt weird about it. They're gonna be like, why do you have so many books? Are you an idiot? Can't remember anything?
You brought too many books. I brought no books.
Yeah.
So
you should. Every desk is covered. Bring your structural analysis book from class. Bring mechanics materials.
Man, there's principles there with geotech books, with mechanics and materials books. And you're like, oh, why would I ever need that? Oh man, they not very often, but periodically would reference them.
Yeah.
Oh man,
it's not going to help you in your house. Just put it in your bookshelf at work.
Put them in your book.
Everything.
I took differential equations in college. Yeah. I have the differential equations book at work.
Just in case the steel starts flowing somewhere.
Just in case, because
beam bending is differential equation. Yeah. We don't deal with that.
But you don't want that at your house. You don't want to remember that class, so it was okay. But anyway, so that was the first half of the first day. And I got really lucky. The firm had 2 senior principals and then 2 or 3 associate principals. And the firm was about 15 people.
Wow.
So it was a pretty good ratio of principal to all the other
to normal.
2 or 3 supporting staff.
Okay.
HR, accounting, marketing, etc.
Yeah.
So okay, size firm, a little bigger than your first experience.
Yeah.
I'm kind of glad I didn't know the projects they actually worked on, because that'd be super intimidating.
Intimidating a little bit.
Super intimidating. And it turns out they do massive projects, big buildings. They've put up skyscrapers in downtown Portland, Oregon.
Should we talk about that real quick? Kind of picking the firm, making sure that the firm that you're applying to or the job you accept aligns with kind of what you're hoping to get to. We're a little tangent here, but we started on different ends of the spectrum. Totally, right?
Completely.
And I think a lot of times if you start on, not low end, but a strictly residential, heavy on prescriptive design,
Sure.
I don't know what you want to call it. This side.
Yeah, if you have from this building, the world,
Yeah.
first world trade
If
center
you wanna
versus
do
a house
this,
kind of firm.
you probably don't want to be at a house-only firm, even to start,
Yeah,
I think.
I would agree.
Because that's going to lend into your next job. They're going to say, what type of projects have you worked on? And if you say,
Residential.
I look at the IRC and I've sized a lot of joists, they're going to say, this isn't a good place for you, I don't think.
Absolutely. Yeah. No, I think it's a very, very good idea. Like when looking for firms and picking one, that you pick one that.
Even if you're like, your pay is less, your title sounds worse.
Yeah.
Like if you're at the type of firm you want to be at, and
That's all
you're
that matters.
the intern to the intern, I think that's probably better than being like the head of the interns. Like, something just trivial.
You start as a principal your first day.
It's like, it's a cool title because there's only 2 people, so you're the vice principal, whatever.
of interns.
Yeah, I don't know.
Yeah. I agree. I think it is really important to have a good pick, and I didn't think about that at all. Like, I got that job, and I was like, sweet.
Yeah.
Like, okay. Got a job.
Oh, that's definitely. I was like, yes, I got a job.
Yeah.
Like,
I don't know what they do.
Yeah.
You know, I mean, to be honest,
it says structural.
they're probably
engineer.
gonna hear this, but it was like, okay, structural engineer. They do some buildings. I remember in the interview, I asked them like where they practiced, like what they did and stuff, and they're telling me stuff. I'm like, I don't know what PT is.
Yeah.
I don't know. Sure, okay.
Physical training.
Yeah, there you go. Physical training. Yeah.
I know what it is.
Yeah. Post tension. Yeah, like stuff like that. Like I had no clue coming out with my bachelor's, and I think I got very lucky where I got to start and to get all that. But okay. Anyway,
back. What was your first? What were you working
day
on?
number 1. Yeah. So first project, day number 1, was this like. It was at a school, and they had these like new portable classrooms outside the school, and they needed to make steel ramps that went up to them with this roof. They're probably about 6 feet wide or whatever, something around that, with a steel roof. So it was like HSS tube steel going up to the roof.
Were they permanent, or did they move?
It was permanent. Like
Picture
they weren't
like an airplane terminal where the classrooms are the airplanes.
Yeah,
and they dock
so it's
with this
more or
thing.
less like for lack of better words, like a double wide.
Yeah.
Yeah, and so it is on wheels, and it doesn't really technically kind of have a foundation. It kind of sits there, but we had this like whole ramp system that went up to it. I've never done this ever again in my career so far. I've never heard of anyone engineering these. I think they're more or less into cataloged items. So, it's kind of funny that was like the first thing I got to work on. It was a very custom thing for this one very specific project. So I got to work on that. Like there was this ramp with a platform, so I designed some of the beams of the platform, the beams of the roof. We had like metal deck, it was all steel, and then the columns, right? So kind of went through that. The principal, we sat down, went through the loading because I had no clue, right? Where I went to school, like we went through all this, and okay, I know how to get the loads and stuff, but what does that mean? How do you apply that? How does that really get through it? It's like trying to connect your loads with your material and that kind of thing. And it turns out you just look at your shears and moments, and you can figure out what you need for certain materials. Now that I think back, or not think back, but like everything's just shear moment, right?
Mm-hmm.
And deflections. That's like all that drives everything. And then every material is designed off of that. But then there's just nuances per the material.
Yep.
Right? Everything has a shear. Everything has got a moment. More or less very rudimentary. Or, torsion. There's a whole bunch of different factors to look at. But every member is going to have those. And then it's just depend on your material. So we kind of sat down and talked about the loading. He helped me get to loading. And then he was like, okay, go run these by hand. And it took me days. I probably designed 2 beams in 1 column. It probably took me like a day and a half, maybe 2 days.
Oh man!
And I kept going back to the principal over and over and over again.
Was this like you had some software and you were just typing in?
Yeah,
slowly,
so they were
like
super big into me doing everything by hand. Like that was the thing. As a new engineer, everything was done by hand. Period. Eventually, you kind of got into other project managers or whatever. They were like, "I just use the software," but the big print, like the principles of the firm, not the people, but the ideology, whatever that word is.
Yeah.
The ideas of the firm is like you'd start off and you just do everything by hand. And I think that's huge. That's key. Like it's so much easier with software, but you don't know what you're doing.
Yeah.
Like, you don't know if the outputs
black
are right.
box.
It's a black
It's a
box.
black box.
It's such a black box. And Matt, I mean, little side note, matter of fact, today that happened to me.
Really?
That was an issue today. Yeah. So we have this beam we're cantilevering out. Well, we need to tighten up the beam, but the backspan can stay the same. We need to shorten up about 6 feet of a 10-foot cantilever for like penetrations to come through for mechanical. So we're cutting off the bottom flange of the wide flange beam, and we're going to raise it up. And so I need to put a new plate in there. I need to run it back through to develop the plate and stuff. And I was using a piece of software to develop the section properties of that. Very easy calculation to develop the moment of inertia yourself, but with software you can iterate.
Yeah,
that's a nice thing. It's so much more efficient to be able to iterate than by
and
hand.
Store, which I like.
And store. And
hand calcs you can put in a folder, but everything in a computer is just labeled well, and you can go back, and that's wonderful. So
absolutely. So I did that today. Boom. I shortened it up. It was a 30-inch beam. I shortened it up to 24 inches, and it was like with a plate that was about the same flange width and size and everything like that. And I did that, and it was like double the moment of inertia of the actual beam. And I was like, man, that's not right. That's not right. But if I didn't do stuff by hand, like that one's a very extreme because you should just know that anyways. But I closed the program, reopened it, and it just cut the moment of inertia in half.
It can be glitchy.
Super glitchy. But if I would have gone forward with that, the beam would have failed. Right? So like using software, but you could go both ways. Like by hand, you could mess up your hand count too.
Oh, for sure.
I think it's really important to like have that good gut feel. Like, okay,
that structural engineering intuition.
100%. Okay, my beam is shallower. Should my moment of inertia be bigger? No, not at all. No. Now then I started playing with the bottom flange, thicker, wider, and then that grew my moment of inertia. I figured out how to have an equivalent eye for both the 30-inch beam and the 24-inch now shallower beam, and then develop all that. So anyway, side note, that kind of happened today, so I thought it was kind of interesting to I could kind of tie that with that scenario.
Yeah. So I think that's something that's important, is like that intuition, right?
Is very important.
And that takes that develops your whole career.
Yeah. I think
that's not something I have. It's like, it's, you get there.
You get there.
It gets better.
Yeah,
but
100%.
Well, my first week, I would have no clue. That's just no way. That feels wrong.
I think you got to do a lot of buildings. Another one too, I think you got to go on a lot of site visits. I think that's really important to a new engineer. But another, I think, a podcast we can go over.
Oh yeah.
Like some big things that you should really push towards when you start engineering. So anyways, first day, design those, kind of drug into the second day and things like that. Then I jumped into some shop drawings.
And what are shop drawings?
Yeah. So they're kind of like they are. Once you design your building, you have your set of drawings, your calculations. Well, then you go into construction. Well, fabricators will develop drawings for their own self to then fabricate off of. So our beams don't tell them the exact dimension, because there's a whole bunch of different things that play out on that, and how to drill the holes,
fit up and coping and
all
everything.
That kind of stuff. Yeah, so they develop their own drawings for their shop guys to fabricate straight from. So their shop drawings, and then we review them to make sure they match the drawings, make sure we didn't miss anything. It's like a good second check. We're like, oh, maybe I need an extra piece of steel here. A lot of times that's just for just the ease of construction, right? So I reviewed some steel shops. The one I really remember doing is rebar shops. So the guy putting the rebar in made a set of shop drawings, and they're super in depth, super long, and I had no clue what I was looking at. It was a building. I didn't design right.
It's hard to do that.
It is,
and that's
really
a
hard.
bad position to sometimes put people in to do shops on a building that you don't know anything about.
I think if you give them adequate amount of time, for a new engineer, you gotta give them a lot of time.
There's a lot of time no matter what.
Yeah, and if you give them a lot of time and you go through it, with them, then I think it's okay. But it's really hard if someone else's design. I don't think they have the final say. Yeah. I think the project engineer still needs to run through it and should review it as if you didn't review it at all.
I almost wonder what's better. You know the project really well, and you're almost skimming through because you just know the bars at 16 inches on center, and you just flying through, and you're going a little too fast.
I think it definitely can happen.
Or on the flip side, maybe if you don't know anything, you got to check every single thing. Yeah. You're more likely to catch something, maybe. But
I would say someone with a lot of experience can go through it quickly and be efficient
and
at
be
it.
accurate.
I think some maybe a year or two in, and they did the project even, they probably might rush through it and miss stuff.
Yeah.
Because a very experienced engineer is going to look at those key elements that have been missed before, right?
Yep.
It always comes back to that. It's like things that they've missed before, right? And so they're checking it more often, and there's the big key elements too, like maybe missed in construction. At one point, it's hard to fix. There's a lot of those where like, okay, I need to make sure they have to have these in there because it's really hard to fix in construction if they miss them for some reason. So anyways, did shop drawings, massive concrete building. I had no clue what any of this was for, like at all. I was like, where do I find this? And the engineer that I was reviewing it for, like, took me through everything very, very easily. It kind of showed me, okay, the ad bar over this column, this is where you'd find it. And a lot of things I either thought would be on the plans.
Yeah.
But majority of the rebar is it called out in the details for these big concrete slabs. I had no clue.
And that varies by firm.
It does.
It does.
Right.
Right.
Yeah. This was a big.
But that's pretty typical, I'd say.
Post-tension slab.
Added detail, column cut, extra bar.
Yeah. But like, okay, you have maybe a slab opening, right? Well, you have extra bar in that. Well, the firm I was working for called that out in a detail, not on plan. So it was like I had to go to these details to find it all, and I had no clue because in school you don't go through drawings.
No.
Right? Maybe as an architect you do.
Nah.
Okay. So yeah, structural engineering, you don't look at any drawings ever. And I think that's a huge gap, but again, another conversation for sure. So reviewed those. That was like, man, okay. That took a couple days, and I was so lost. There's all this bar. I'm like, I don't even know where you find this. And then like there's these stands that hold up the bars, and I was like, where do I find that in our drawings? And it turns out like, that's not on us. That's for someone else to figure out how to hold the bar where it needs to be.
Did someone comment on how long it took?
No, never,
Okay.
never. All the job, no, like. The next job that I kind of jumped onto, they did kind of tell me how long it should take, but they didn't mind that it took way longer.
Yeah.
So, So the next one I did was this wood beam on a house. We didn't do much residential, if really any, maybe a couple houses a year, and they're usually favors. Right, I think that
friends of a friend kind of.
Yeah, or like an architect or something like, hey, we'll design your house, but it didn't very commercial firm. And the house had this big balcony and needed a beam across the front, and it had joist framing into the beam. Right?
Yeah.
5 years experience, easy, right?
Easy.
What do you think that calc takes you?
I'm already done.
Yeah, I took probably 2 days. So I was told by the principal, we sat down, we talked through it. I was like, okay, we're good. I'm now, for this one beam, he's like, use this software. I'm like, okay.
Do you remember what the software was?
I think it was called Struck Calc.
Struck Calc. I don't even know Struck Calc.
Yeah. And you design beams in it, and I was like, okay, I've got joist of 16. I'm gonna have a point load at every 16 inches from the trib on that joist. I did that. And it was, 20, 30 foot beam, and I had a bunch of point loads. Well, Struck Calc only lets you do 8 point loads or something like that. So I went back to him. I was like, I don't know how to do this.
It's not possible. This is too complex.
There's too many point loads. The program will not do it. Gotta do it by hand. And he goes, no. When you get point loads that close together, it's just now a tributary loading. It's a distributed load on that beam. You don't need to do point loads anymore. And that was like a first big learn.
Yeah.
I was like, wow.
I'm curious now, what's your ballpark? Other circumstances, out.
Yeah.
How many point loads does it take to be a distributed load?
I think five-ish.
Okay.
It so depends on span.
It depends on
Depends on span. But on this scenario, it is blatantly a distributed load, right? You have joist 16. It was 16 or 24 inches on center, framing into this 30-foot beam. It is blatantly half the load is going to that beam. And I don't think anyone will argue that one. Yeah. Right. And so I get into the program. I open up a wood beam again. Not again, I guess, but I've never taken a wood design class in school, so I had no clue what I was doing. And he's like, oh, just go figure it out. But, we went over stuff. He's like, go back to your desk, open up the program, put in the beam, calculate, put in these loads we went through. After I went back to him, and I was like, I can't put in all these point loads. So I did that, went back to him, and I had it was a huge solid sawn beam. So just cut right from a tree. And it was like a 4 or 6 by 18 or something like that. And I went back to him, and he was like, well, first you chose the wrong type of wood. We don't have that wood here. I don't remember what it was, but we didn't have it. Not in the North.
Doesn't grow here.
I didn't have the right grade of wood. And I was like, okay.
Was he nice about it?
Oh yeah.
Oh, yeah.
Absolutely.
Understand a guy. Okay.
You don't have, these aren't right. I mean, you're just blatant with them.
Yeah.
I mean, I think you're just on, it's just like,
Yeah,
none of
to
this
be
is
honest,
right.
This is
I'm
wrong,
like,
this is
okay,
wrong, this is wrong.
here's what you need to do. Like,
The
okay.
length was probably right.
The length, yes. I got
Did
the,
he give you, he's like,
got the length of the beam right.
Okay.
So that was good, but you kind of went through all those things. Like, okay, I'll go back and fix it. And then the big thing with solid design, he's like, okay, when you get past like a 2x12 or something, 12 inch and a quarter inch depth, you'll start getting checking across.
What's checking?
So you'll start getting big gaps in your wood due to the temperature, like fluctuations because it's an outside element, right? So he's like, when we start getting that big, if that's what we really need, we're gonna go to a glue lamp, which is like a 2x element, glued together on top of each other.
This is a manufactured
wood. Yeah. So
way stronger.
Yeah. So I was like, I don't know what that is, but okay. I'll go.
I'll doing it.
So the
drop down
menu,
glue lamp.
solid glue lamp. I'm like, yes. Well, glue lamp, they have different grades, and then they have different wood types, right? Different species. And I was like, I don't know. It just popped up too, and I was like, okay, that must be it. Completely wrong again. So I went back to him. I had the very narrow and very deep glue lamp, and he goes, okay, well that doesn't seem right. And let's talk why. So he started looking through the printouts. Every time he made me print out what my calcs were, and we went through them. And that's something I still do today. Like I print off
to see it on paper.
I print off my calcs and I go through it like for certain things and go through. Okay, that's right. And again, more conversations we can have, but I think that's sometimes really important. Just like a quick second look, because in the program it looks one way, but once you print it, you see it in a different format, and sometimes that can pop out at you. So I think that's still sometimes key, and I use that for like Anchorage software sometimes. Yeah, like it really helps. Just like a really quick second glance.
Yeah, the Anchorage software that's extra black boxy.
Yeah,
that's like proprietary.
Absolutely,
yeah,
absolutely. So go through it, and then the one thing I didn't realize is like there's more than just the beam, right? You got to detail it. The joists coming in have to have a hanger that they sit on, and then that has to screw into something. So if you have a really shallow or narrow beam, that doesn't work, right? Like just screws are
pop out the other end
and all this stuff. So, and then you got to think about how the beam is framed into the walls and all, or into the post or all that kind of stuff. So he talked through this with me, and this all happened over probably a day, maybe 2 days, like just to design one beam. I came in there and I was like, I have some patience.
He's
so patient. And I think that's like such a big key when you're starting your career, is like finding someone that has a lot of patience and like willing to do that. So did that with him, and then I think that week kind of really was just nervous most of the time. I honestly like went home almost every day thinking, man, am I gonna have a job tomorrow? Like they must think I'm a joke because I can't design a beam. And like if I sat there and designed a beam like school, by hand,
it's like a homework assignment.
A homework assignment
take a little while.
Probably been quicker though. I think so. It was just like trying to connect the two was a big one too. It's like, okay, we did this in school. Now we're doing this here. What does that mean? How is it similar? So definitely some very patient people I worked with initially. I worked with one of the PMs week 2, 3, maybe even within the first like later in a month of starting, and he gave me it was like a post on a roof that you then attach your man that's up there, whatever, like you tie off. Worker, exactly. So, or they go out there it was more so for like fall protection for after the building was occupied. So someone up there to clean something they could tie off to it. So he gave me this 40-page design guide, and he goes, okay, design. So I went through and looked up some things in there, and I went to that structural software I used before for the beam. I was like, okay, here's my cantilevered column with a point load. Okay, design that as like a round tube. And I talked to someone there about welds and how to design a round weld, and went through that. Okay, cool. I went to him with the print-offs on that, on the post and stuff, and he went crazy. So, not crazy, but he was very upset with me.
He was emotional about you.
Yes, absolutely, that I didn't do it by hand, right? He's like, I gave you this design guide. You should have done it by hand. And so I think that's a big one too. It's like expectations and like communication is so big, especially when you start. Always.
With anything.
With anything, it's just like, make sure you're overly communicating when you start as an engineer.
Yeah. Ask the dumb question. Just ask it.
Ask the dumb question.
Do you want me to use a pen or a pencil?
They don't really care.
Right on my hand?
Yeah.
Or should I?
They don't care at all if you know it or not. It's the thing that I learned is like you can make a lot of mistakes once.
Yeah.
But
That's what I say. You can ask a dumb question once.
Yeah, but when you ask
Ask
that
it
same question 1,000 times, that's when you have the problem,
Yeah.
right? And that's what totally I think every firm sees, right? Okay, you ask the question once, even if it's dumb, like really, how do you design this beam, right? Like
Yeah.
as a 3 month, you get into engineering, like beam is the easiest thing to design majority of the time, right? It's usually restrictions from an architect with building layouts and all that kind of stuff that really cause issue in engineering, not how to design the beam. So asking that question once is okay, but when you start asking that question 5, 6, 7 times, it's like, okay, they're not getting at what's going on.
I think as we're writing down, you should write things down. It's a very good habit, especially, man, like your first job, because you're going to forget so much because you're hearing way too much that you can remember.
Have a reference
to
book.
be like, yeah, here's how you
know
a
what?
beam.
Yeah, the first probably 6 months, I photocopied my calcs and kept them in a binder.
Really?
Yeah.
Yeah.
I don't have the binder anymore. I wish I did. But
go back and check. You probably don't want to see it.
Yeah. But I kept a lot of things in there that I was like, oh, for sure. There's some one-off things I've never even done since then, but
I had some weird stuff photocopied. I have like anchor bolts embedded in concrete for a long time until I just memorized it, which took a while.
Yeah.
It's like, what were the steps for this thing again? Because you don't want to ask. You don't want to, waste the time looking it up if you don't have to.
Yeah.
So
it's all about efficiency and how you can do it quicker and better and faster.
I just know I've got this one page. It's a one-page calc. I take a peek.
Yep.
Do it again.
Yep. Yeah. Exactly. Less things you have to memorize.
Write it down.
Yeah. So that was pretty much my first month. Like I said, I was pretty scared. And second or third week, I started going home after work and just studying. I had all my notes and stuff from school, and I started studying like everything.
That's funny you mentioned that. I actually studied before every single one of my jobs when I kind of moved up in firms.
Yeah.
I had this very little in engineering internship before the one I mentioned, actually. But I was more of an architect.
Yeah.
And then before that, I hit the books hard. And then for this other one, I read everything I could. And then kind of moving more into commercial, I read all about steel buildings.
Yeah.
Because you need a little background. And I bet a lot of people do that. I hope they do.
Yeah. Oh, yeah.
Even if you don't use any of it, you'll be comfortable with the lingo and have some expectation for what you're going to be doing.
Yeah, absolutely. Yeah.
But
I would say it was probably 2 weeks straight, at least.
Every night you just go home and
probably 2 or 3 hours, yeah. Going through over all the old lecture notes and homeworks and stuff. And I was like, man, if I don't get this, and it turns out firms understand that probably the first year of a new engineer is not a win.
Yeah, now in retrospect.
You're going to lose money. And that's how it is. That's how everyone is. Everyone.
Yeah.
So there's nothing to be scared of if you're going into your first job, or it's just learning and asking the right questions and continuing to learn. Something Max and I are pretty big into is just getting as much knowledge as you can. Yeah, absolutely. Even things that aren't even within your discipline, really learning more about geotechnical, electrical, mechanical.
Oh yeah, absolutely. Across
things
the board in
with
AEC, architecture, engineering, construction.
Yeah, understand more what the architects are dealing with.
Yeah, just talk to everybody.
Yeah, and just the more you know, the better you look to your client, your boss, to your peers. I mean, I think as long as you keep learning, you'll be a good engineer and you'll be successful. So
what do you think? Sort of on closeout here. What are the biggest takeaways that you wish you had done, or you did, and it was good? And
I think the biggest thing is I wish I would have known that I shouldn't have been as worried.
Yeah, that's
I think that pushed me really hard to learn faster and quicker and study and stuff. But I think I was overly worried that I was going to lose my job in the first month or two.
Yeah, I think, I didn't have anyone to keep up with because I was the only one there for a while. But I feel like, in later jobs, moving on to more challenging projects, thinking that I should be keeping up with the next person on day one.
Yeah.
No, it's not going to happen. If you try to, you're going to screw up.
Yeah.
Just don't,
As long as you work to keep moving and
keep progressing.
And progressing.
Do better every day.
Yeah.
you're not.
That's
gonna
all that
go.
matters.
Yeah.
Yeah. As long as you're not going backwards, which I think would be kind of hard. I don't know how you do that. Like, I'm going to forget everything I learned yesterday. You know, like, how would you do that? But
Start -2.
yeah. So, yeah, I hope this is super helpful to new engineers,
Yeah.
new people, and it gives a little insight about us, our
Absolutely.
experiences, and what we can kind of help bring to our audience.
If you have
moving
anything
forward.
you want to hear, again, we're going to kind of cover everything. We'd love to do some interviews. We'd love to cover a little more technical stuff material. And
I think we'd really like to just talk with our audience, you
And just
know?
talk.
Like,
just...
yeah, like,
Well-
if you know, have them reach out to us and ask us questions. And I'm sure today we missed out on things. We missed some things, or maybe we went on a tangent and didn't come back to what we were actually talking about. And, you know, there's follow-up. So I think there's platforms we have, Facebook, Instagram, email, etc., that, you know, we have set up.
Do we have an email?
We'll have set up soon.
We're...
that, you know, we'll post with everything that you can reach out to us and, like, feel free. I mean, I think don't feel intimidated at all to reach out to us with any questions.
Yeah.
Even if you're looking for your first job, you know,
Give you some pointers, I guess.
some pointers.
We can try
or,
at least. Can't hurt.
Can't hurt to reach out to us. So,
Cool.
yeah, thanks for joining us today. I'm Zach,
I'm Max.
and we'll see you next week.